Hey everybody, it's Mr. Carr again. Today we're going to be talking about 2C Day 2. We're going to be talking about what's called percents. Percents are actually a continuation of what we did in the last class. They are going to be proportions. They're just a very specific type of proportion. Okay. So when we did before, we talked about ratios and proportions and how to set them up and solve them. We're now going to be applying those to today when we solve our percent problems here. So what are percents normally out of? Okay, it's actually kind of in the name. We say percent, okay, means out of 100. Okay, cent, you've seen that before, century. Centimeter. There we go. That's another one. Century, centimeter. That means 100. Okay, so we have this format where percent is going to be, we use a little symbol, we call it, looks like this. We use this general form to solve percent problems, and that's going to be the percent over 100. So when I talk about percent, if I say 20%, for example, that is 20 out of 100. We can use this little proportion here as pretty much consistently every time. And it's going to be following this pattern. If we have an is number and an of number, it's going to go in that order. Percent over 100 equals is over of. And then hopefully these next will kind of clear that up. So for example, what percent, okay, is 252 of 252 is 84. The percent is the unknown thing. So I'm going to call that P. So I'm going to put P over 100. The is number is 84. And the of number is 252. Okay, that's it. That's my setup. I'm going to do the same process and everything. Kind of have an unknown number, and that's what's going to get my variable. Then fill in everything else. So what number is 30% of 90? So I have my percent, which is 30 out of 100. Okay. Then I have the is number is what the unknown. So I'll just call that X. And of 90. So of is on the bottom there. All right. And then one more style we can do, find a base of. 16 is 20% of what number? So my of there, oh, hold on, I'm freezing up on here. Let's make sure. So much fun. Let's do that. There we go. Okay. We'll start with this. 20 is going to go over 100. That's my percent. The 16 is, that goes in the is position. That's the upper part of what number? I don't know what it is, so that's where it's going to get X down there. Okay, so 3 types of percent problems. You're either looking for the percent, you're looking for the is number, you're looking for the of number. You just need to fill them in based on that description where they belong. And then I didn't do it in this case because we'll do them on the problems down here, but then you would cross multiply here. Okay, just like we do with our other proportions, we would cross multiply in all 3 cases here. So let's talk about these then. Write and solve these equations. What percent? That's my unknown. So I'm going to go ahead and go right to P over 100 of 50. So that'll go down below is 33. Okay, and that's it. So now I can cross multiply. I've got 50P equals 33 times 100. So it's just going to be 33,300. Divide both by 50. So my percent is going to come out as, is it, double check here, but I believe it's going to be 66%. I am correct. 66%. Oh, let's do it again. Sorry about that. My technology is being super fun. There we go. Okay. So that's my answer there. And I'm just going to leave it as 66%. There's no other real context to do besides that. Number 2, what number is 75%? So 75 out of 100 for percent of 164. So that's going to go below number. The unknown number is X there. Okay. Now this is a good example where I can reduce this to make things easier when I work forward. So 75 out of 100 can actually reduce down. Okay. If I divide both of these by 25, then I can actually rewrite this as 3 over 4 equals x over 164. Just easier work with smaller numbers, but you don't have to. So I'm going to go ahead and cross multiply here. So I have 4x is equal to 3 times 164. So 4x is equal to 3 times 164 gives me 492. And then we'll divide both sides by 4. And I get 123. So that's my unknown number. So I can kind of make this into a statement. 123 is 75% of 164. Number 3, what percent of 76 is 57? So again, my unknown is my percent. So I'll put that over 100. The of number is 76. The is number is 57. So I'll go ahead and cross multiply now. So I get 76p equal to 5,700. And then we'll divide both sides by 76. So divide by 76 gives me 75. So again, that is 75%. And then the last one on here, 40% of 30 is what number? So 40% of 30 is what number? Okay. And again, I can reduce this. So first thing I'm going to do is I'm going to get rid of the zeros there. So I got 4 over 10. I can divide by 2 for both cases. So it'll be 2 over 5 equals x over 30. Just make it a little bit easier on myself. So I'm going to have 5 times x equals 2 times 30. 5x equals 60. Then we divide both sides by 5, and I get x equal to 12. So 12 is 40% of 30. Okay, so these are our basic percentage problems. We're also going to be able to apply those to some word problems. Okay, so we got 4 and 5 to go over here. So Maddie's about to take finals and wants to get at least an 85% on the final. If the final is going to be 123 points, how many points does she have to get right in order to get her 85%? So another way of thinking this is she wants to get 85%. So we're kind of saying this. 85% of 123 is what number? Okay, tying it back, that's a way to kind of reinterpret this. 123 is the whole pieces, okay? Didn't say it, but lots of times we do percentages as percent over 100. So lots of times we do percent over 100 equals the part over the whole thing. So that's another way of, instead of just is and of, we can say the part over whole. So for example, the score that Maddie gets, that would be a part of the potential points. The whole number of points is 123. So for my setup, I would do 85 over 100 equals some value over 123. Okay, and we'll cross multiply here. So I get 100x is equal to 85 times 123. 100x is going to equal to 85 times 123 gives me 10,455. Then I could divide by 100. So I get x equal to 104.55. So if she wants an 85% on her final, depending on how the teacher grades, that's the score that she has to get. I don't know if this teacher is going to give 0.55 points, so maybe we round it up to 105, and with a little bit of flexibility with the context here, okay? So Maddie needs to score at least 104.55 on the final. Okay. All right. 2 different stores are selling a bike you want to buy. At store A, the bike is on sale for 20% off the original price of $240. How much money will you save? Okay. So again, to reinterpret this, the original price is going to be my of number. It's my whole number. Okay. So this will be the of 20%. So the money you save is what we're solving for. So 20 over 100 is equal to X over 240. And so, I forgot to do this earlier. Let me reduce this fraction a little bit here. So I can actually cancel out the end zeros. 1 over 5 equals X over 240. So I will cross multiply here so that I get 240 is equal to 5X. And then we'll divide both sides by 5. I don't feel like doing that in my head right now. So I get 48. Okay. This is the 20% price. So that's how much is being saved. Okay. So you would save $48. At store B, the bike is on sale for 25% off the original price of $265. So it's the same setup. How much will you save here? So instead, we're going to do 25 over 100 equals X over 265. Same idea as before. I can reduce this fraction here, 25 over 100. That's going to reduce down to 1 over 4 equals X over 265. And then I can cross multiply. So that 4X is equal to 265. Okay, so 265 now divided by 4. X is equal to 66.25. Okay, and so in store B, you would save $66.25. So this is a good question to kind of help explain some of our context here. Which bike should you buy? Oh, man. Okay. This is very frustrating now. Okay, so I did all this work. So let me just highlight that again instead of rewriting it. So we did 25% off the original price of $265. Sets up very similar to the previous problem. So I'm going to put 25 over 100. That's my percent. X, my sale price, over 265, the whole normal price. And then I reduced this fraction down to 1/4. And then we did cross multiplication. So that's 4 times X. Let me just show that right there. Okay, so I reduced that fraction down, and then I did my cross multiplication here to get 4X equals 265. Then I divided both sides by 4 here, and I got X equals 66.25. So that's how much is being saved. So now the question is, what's the better deal? Be careful. Some people might think, oh, 66, you're saving $66. That's the better deal. But you're also saving on a higher original price. So if we want to truly compare this at store A, the actual price that you buy the bike is going to be $240 minus $48. Okay, so the actual sale price is $192. At store B, it's starting off at a higher amount and it's taking away 66.25. And you can hopefully can kind of see it already. Oops, 0.25 will come out as 198.75. So even though it's got a better sale, like 25% gets you more savings than 20%, the problem is store B started at a higher amount. So even then, in the end, it's going to be higher there for 198. So store A is the better buy. Okay, and that's it for our percents. Remember, the big thing about percents is that they are a very specific type of proportion. We are showing the ratio of percent out of 100 compared to an is over of idea. But I could also do, instead of is over of, percent over 100 is equal to a part over a whole. Okay, so a small section or a small part of the entire thing is the idea there. Okay, and that is it for today. So reach out if you have any questions, but that's it. Take care, everybody.